So we want to find the exact value of sine 22.5. We know it's going to be a unit circle value, and that's pretty easy when you see the 0.5 to think half angle formula. If I doubled this 22.5, I would get 45. So this is equal to the sine of 45 degrees over 2. Now we're going to use the half angle formula. So sine of 45 degrees over 2 equals, in the half angle formula, I'm going to actually write the half angle formula first. So sine of angle over 2 is plus or minus the square root of 1. Sine is minus cosine of alpha over 2. So the plus minus does not go in the answer. It's just it could be a plus or it could be a minus, and you just need to look at the quadrant that your half angle is in and determine the sign there, SIGN of the sign. So since 22.5 is in quadrant 1, I know I'll want the positive, so I don't need to list it. It's going to be the square root of 1 minus cosine of 45 over 2. So now we're going to replace that cosine 45. We know 45 is right here in quadrant 1, and 45s are square root 2 over 2. So this is going to be square root 2 over 2, and then that's over 2. Now that's all underneath the radical. One thing we're going to do is we're going to get a common denominator, make this 2 over 2 so that I can combine them. I'm going to come down below my formula to rewrite this now. So it's going to be 2 minus square root of 2 over, and it's actually going to be over 4 because here I take this 2 over 1 and I flip it over to multiply it. So this is going to be 1/2. So the common denominator here was 2. And then multiplying that other 2 in there gives me the 4. Now the last thing I'm going to do is I'm just going to write the radical to the numerator like this, because when I apply the radical to the 4 here, I can just get 2 outside of the radical. So there is my answer in exact form. Now let's look at another one that involves radians. And we can see that the sine of pi eighths is the sine of pi fourths divided in half. So now we can use that half angle formula. So the sine of pi fourths divided by 2 plus or minus, well, pi eighths is in quadrant 1, so plus. Had this been something that landed in quadrant 3 or quadrant 4 where the sign values are negative, then I would have used the minus. But this one's going to be plus square root of 1 minus cosine of this angle here, which is pi fourths, and then over 2. So square root of 1 minus cosine of pi fourths is square root 2 over 2, and then that's over 2. Now this is looking just like the one we just did. Well, that's if you look at it, because we had pi fourths over 2, or we had 45 degrees over 2, and they're the same angle. So we would expect to get that same answer. When we get the common denominator, we will have 2 minus square root of 2 over 4, and then we will apply the radical to the numerator, and the denominator stays in the numerator, but square root of 4 is 2.